All right, here we go. So section 2, part 2 is a review of more pre-calc concepts, but this time we're going to talk about exponential and log equations and using a graphing calculator. All right, so the first one, so it says solve the exponential and log equations, write the answers in exact form, and then approximate to 3 decimal places. So have your calculator out and ready, because we're approximating. All right, so when we see a log minus another log, do you guys remember what the rule is for that? We divide, right? So we're going to combine these two logs with log base 2 of x minus 1 over 2x minus 1. And that's all equal to 3. So that comes from the rule log of a minus log of b is equal to log of a divided by b. That's where we're getting that from. Now I'm going to switch it from logarithmic form to exponential form. Do you guys remember how to do that? 2 raised to the 3 is equal to x minus 1 over 2x minus 1. Okay, it's like a little do. Use your hand, back and forth. All right, so 2 cubed is 8. So I have 8 equals x minus 1 over 2x minus 1. And I'm going to multiply the 2x minus 1 to the other side. So we have 16x minus 8 equals x minus 1. So 15x is equal to 7. So x equals 7 over 15. I know I went speedily on that, but remember, be an active note taker. I see a lot of you guys looking up and looking down, looking up and looking down. You guys know how to solve it from here, right? So just solve it once you get to that point. Don't look at my answer. All right, so we get 7 over 15. Now I would always do a quick check. Go back to the original. If you have 7 over 15 and you do 7 over 15 minus 1, what do you get? It's a negative number. So is the answer really 7 over 15? Isn't that frustrating? This is actually no solution. Because if you plugged 7 over 15 back in right here, you would have a negative that you're taking the log of. And that makes it undefined. Okay, so you always have to check, especially in AP Calc. All right, so no solution. All right, so this next one, I have addition. So that's the one where it's like log of a plus log of b is equal to log of a times b. So as long as they have the same base, we can, if we have addition, we use multiplication to combine them. All right, so I'm going to have natural log. Oh, this is a little tricky though. Do I need to do that?
No.
I actually don't. What could I do?
Get rid of the L and E.
Yeah, when you have natural log of e next to each other, it kind of cancels. Does that mean that the 5 is just kind of hanging off in space? No. So we have a couple rules going on here. We have the rule where we're going to pull the 5 to the front, and then we have times natural log of e. Well, natural log of e is 1. That's why that goes away. All right, so we use the rule where it's like log of a raised to the c is c times log of a. So if you need to write these rules down, you can. If not, that's fine. So natural log of e are gone. So I'm going to have 5 plus natural log of x minus 1 equals 7. So I subtract the 5 over, and I get 2. Now this, when you guys were in Algebra 2, you had a hard time switching into exponential form when we had a natural log. It's because you don't see the base. When you see the base, it's like, oh, wait, I totally know what to do. Well, what is the base for a natural log?
E.
It's an e, right? So put a little e there if you need to. So what we're saying is e raised to the 2, so e squared, is equal to x minus 1. So as an answer on the AP test, you could leave it as e squared plus 1, or you can round it to 3 decimal places. So if we have e squared, and then we add 1 to it, our answer would be x equals 8.389.
Can we leave it as that on your test too?
E squared plus 1, sure. And if it's a non-calculator, then you have to, right? Non-calculator test, you remember those? That happens. All right, here we go. So the next one. So this is already set up so it's in logarithmic form, so we're going to switch it to exponential. So we're going to switch, and we have 9 to the 1/2 equals x squared minus x plus 3. 9 to the 1/2, do you guys remember what that is? It's 3. So when I subtract the 3 from both sides, I end up with x squared minus x. So we know that we're going to factor out the x, right? We did one like this the other day. Factor out the x, and we're left with x minus 1. So we get x equals 0, and we get x equals 1. All right, do a quick check. If you plug in 0, is it okay? Sure. You have log base 9 of 3. If you plug in 1, is it okay? 1 minus 1 plus 3? Yep, it's okay as well. So both of these are okay. They didn't give you the log of a negative number. All right, so we got a lot going on the next one. So let's combine these two first. We would do that by the division rule. So we're going to have log of 64 over 3, which is, or not 3, 32, which is log of 2. And then we're going to subtract out that log of 5. So it's a little tricky, but we know that that's going to be log of 2/5. So we have log of x minus 2 equals log of 2/5. This is easier than it looks, isn't it? We just set x minus 2 equal to 2/5. That's all you do. So you're going to have x minus 2 equals 2/5. So our answer,
The log of 2 minus log of 2.
What is what?
How do you get the log of 2 minus the log?
I use this rule right here. The log of a minus log of b rule is log of a over b. So I did 2 minus 5. When I combine log of 2 minus log of 5, it's log of 2 divided by 5. So I used the division. All right, so I have 2 and 2/5, or if you got common denominators, it would be 12 over 5. That's 2 and 2/5. All right, good so far? Moving on. So now these are in exponential form. So now let's do the exponential form ones. So when something's in exponential form, so we have a variable in an x as an exponent, we will use logarithms to solve it. Occasionally, you can get them to be the same bases. Do you guys see one where they could be the same bases? E, F, G, or H? F. Do you guys see how you have 64 and 16? You can make it both 4 to the something or 2 to the something. All right, so this one we can't. We can't say 18 is 3 to a power. Doesn't work. Okay, so we're going to use logarithms. Now with this, you can do it 2 different ways. You can switch back to logarithmic form. That would be this way. Some of you are not very comfortable with doing that. The short way that I taught you is you can take really any log of both sides. So I always use natural log. So if I do the natural log of both sides, I'm allowed to drop the x minus 2 to the front. So we do x minus 2 out front times natural log of 3 equals natural log of 18. And then we're able to divide that natural log of 3 over. It's a number, right? So we divide it over. Now be careful, don't think that division and subtraction are related to each other. Don't think that this is now subtraction, right? This natural log of 18 over natural log of 3. We only combine those using our calculator, or we would just leave it like that. Okay? You could actually write it as log base 3 of 18. It's the change of base formula too. But we'll leave it like that. All right, so then I have x minus 2. So you could have x equals 2 plus natural log of 18 over natural log of 3. Or you can find the decimal version. I am totally fine with the decimal version. So you should get 4.631. Now on my calculator it says 4.630929, so on. You can actually, on the AP test, you could have this answer as well, 4.630. You can round or you can truncate, meaning chop off. You can chop it off from there. Personally, I like rounding because if you guys are going to be my future engineers building bridges, like we've talked about before, I want you to build the bridge correctly and as close, as accurately as possible before I drive on it. Yes?
Can we, if we want, can we just leave it with the way we do, like log base 3 of 18?
Yep. So if you had done it in the other way, if you had done log base 3 of 18 equals x minus 2, then your answer might look like this, which is perfectly acceptable. Now the reason we might have had this instead, the natural log of 18 over natural log of 3, is because with the change of base formula, that's natural log of 18 over natural log of 3. You could change it to any base that you want. Do you guys see how those are equivalent? All right. So F. Whoops, I don't know what happened there. I'm writing, but it's pulling. Okay, so F, we are going to try to get them to be the same base. So let's start with 2. So if I have 2, and I'm trying to raise it to a power to get 64, do you guys know what power that is? It's 6, right? So 2 to the 6. I saw Jerome thinking. He had the thinking look. And then 16 is 2 to the 4. So we have that. So occasionally you can get them to be the same base, and you don't need to use logarithms at all. So this is going to be 2 to the 18x minus 6. So we went ahead and distributed this and got that. And then we have 2 to the 16x plus 20. So if I have 2 to some number equals 2 to another number, if they're equal to each other, those powers have to be exactly the same thing. So we're going to say 18x minus 6 is equal to 16x plus 20. So we get 2x equals 26, so x is equal to 13. Do you guys like logs? Feeling good about this? Me. Oh, that's me. Sorry. Hopefully it's not my babysitter. We'll see. All right, anyway, so subtract 3. So we have 12. Divide by 8. So when I divide by 8, instead of writing 12 over 8, I'm going to reduce it. So divide by 4 on top and bottom. So 3 over 2. And I want to get rid of that e. Yep. So just do the natural log of both sides. It always drives me crazy when you guys write natural log on the side here. Like on the right side, I'm like, what are you taking the natural log of? It should go in the middle, like in front of that. All right, anyway, so I get 3x minus 7 is equal to whatever the natural log of 3 over 2 is. So I'm going to find that. Natural log of 3 over 2. So natural log of 1.5 or natural log of 3 over 2 is 0.405 something. Now I keep that number in my calculator. And I'm going to add 7 to it and divide by 3. So that way I have a precise answer, 2.468. Okay, so keep the number in your calculator as you're doing your computations. All right, and then the really hard ones, when they can't be the same base, but they both have exponents, that's where it gets really tricky. You're going to do natural log of both sides. And that way you can pull the power to the front and pull that power to the front. So I have parentheses 3x minus 1 times natural log of 5. And you would start distributing. So you're going to distribute this natural log of 5 into both things. So we would have 3 times natural log of 5 times x minus natural log of 5. Do you guys see what I did? And if you wanted the exact precise answer, you would actually get all of the x's on one side. So you'd have x times natural log of 7 minus 3 times natural log of 5 times x equals negative natural log of 5. Because then you could pull out the x. So you'd have natural log of 7 minus 3 natural log of 5. And then you can divide. So the precise answer, like the exact value, would look very weird. It would look like that. Could you combine it even more? You could totally combine that denominator. You would raise the 3. So you take the 3 and you'd raise it as a power and get 125. And then you would combine your natural log. So you'd have natural log of 7 over 125. Isn't that messy? So that is why I am okay with finding the decimal answer, because that's a lot of stuff for me to like grade. So I think teachers are okay with the 3 decimals as well. So we do get 0.558. Now what happens though is on the AP test, every year my students are frustrated with the natural log section because it's never like a form that I would have done in class. Like it could look like that, or like I said, it could look like negative natural log of 5 over natural log of 7 over 125. So since it is a like a multiple choice test, well, not all of it, there's also a free response, they would write the multiple choice answers in that form, and you'd be like, wait, which one is it? So you really have to kind of think about, how do I get it in other forms? How can I move this around? All right, still good? You could use decimals along the way. Like if you wanted to use like 6 decimals and multiply n, you would get the right answer still, because you could round to like 3 decimals in the end anyway. You could do that as well. All right, so the next one. So we are going to combine with multiplication. So we're going to have log base 2, and then we're going to FOIL x minus 1 times x plus 3. So we're going to have log base 2 of x squared plus 2x minus 1. Oh, minus 3. Oh, speedy. That would have been bad. All right, and then we're going to raise it to the 5. So 2 to the 5 is equal to x squared plus 2x minus 3. So we have x squared plus 2x. What's 2 to the 5th? 32. So if I do negative 3 minus 32, negative 35. So we're there. You with me? I'm going speedily. Factor. We have 5 and 7. We need the plus with the 7 and the minus with the 5. So we have two answers. We have x equals negative 7, and we have x equals 5. But remember, we always want to check when our original was a log equation. One of those does not work. The negative 7, yeah. Because if you plug in a negative 7 in right here, oops, then we would get negative 7 minus 1, which is a negative exponent. Why that moved like that. All right. Can we skip the next one? Are we good? Well, I guess we have different bases, so maybe we should talk about this. So don't let the fact that this has different bases, log base 2 and log base 4, confuse you. Go ahead and work through the problem. If you have log base 2 of 2/3 and log base 2 of 3 over 32, combine them. So you get log base 2 of 2/3 times 3 over 32. So we cancel our 3's. We reduce our 1 and 32 to 1 over 16. So we have log base 2 of 1 over 16. And so some people might panic at this point and say, I don't know how to combine these, right? We can combine these though, because we know log base 2 of 1 over 16 is a number. Do you know what number it is? I heard someone say it, I think. Negative 4. Anjali's so quiet, and she's in the very, very back, but she says negative 4. Do you guys see that? Because 1 over 16 is the same as 2 to the negative 4th power. So it was log base 2 of 2 to the negative 4. So we get negative 4 is equal to log base 4 of x. So we get 4 to the negative 4 equals x. So 4 raised to the positive 4 is 256. So what's 4 raised to the negative 4? 1 over 256. Yep, so even those you can do, so don't be scared. All right, now really quickly so you guys can do your homework. If you are using a graphing calculator, oh, I guess we'll skip that part. We'll do that next time. So I guess we're a day behind on our homework.